Example 1, part A, question 1, or question A. I'm going to describe any key features that I see for this graph. First of all, I want to talk about the intercepts. Those are the first things that we should go to when describing key features. And on this function, I notice that right here at a height of 2, that's the y-intercept. To write it in ordered pair form, 0, 2. Right here, as the other intercept that we should always be looking for, we see the x-intercept. And in ordered pair form, that's 4, 0. Some other key features that we were asked to identify. The function is positive because nowhere does this function go below the x-axis into negative land. And also, as we move from left to right, the function is decreasing. I don't see any indication that the function changes and becomes an increasing function over in this region where we don't see the graph. So I'm going to make the prediction that this function is an always decreasing function. There's no symmetry. There's no left and right side of the y-axis or up and down nature. So I'm not describing symmetry either. But to reiterate, the y-intercept, the x-intercept, the function is decreasing. The function is always positive. The lesson is titled Domain of a Function, so we want to focus on that. The domain of a function is related to possible x values, where you pick an x value, can you go up or down from that x value and find the graph? For example, if I pick -2 as my x value, can I go up or down and meet the graph? And I do. -2 has a related y value. I can choose different x values as well. -3, -4, -5. If I go up to the graph, or if I go up from those x values, I'll find the graph. The same is true at 0 and at 1 and at 2 and at 3. If I pick 2 as an example value, I can go up, find the graph, and find a matching y value. Where that fails to exist, are there any values of x where the graph does not exist? Yeah, certainly. If I pick 5 and I go up or I go down, we never find the graph because the graph here of f of x, it stops after a certain while. Same is true of 6. Go up or down from 6, you never find the graph. So therefore, 5, 6, probably 7, 8, etc. You know what? Any number bigger than 4 is a way to describe this. Because what if you're in the space between 4 and 5? What if you're in the space like at 4.5? You go up from 4.5, down from 4.5, you still don't find the graph. So are there any values of x where the graph does not exist? Yes. We've mentioned 5, 6, 7, and 8. In fact, any number greater than 4. When we talk about the domain of a function, these numbers are not in the domain, any number greater than 4, because they don't point up or down to the graph. To go back and answer what goes in the second bullet, there's things like -6, -5, -4, skip a few, 0, 1, 2, 3, even 4. 4 is a filled-in circle. So 4 is also places where the graph exists given that you pick an x value. So to turn this into a domain, let's also use the proper word, domain of the function. It's any number of x that is less than or equal to 4. When I use this symbol right here, I'm using what we call inequality notation. I said it in words, so I might as well write it. Any number less than or equal to 4. That's how I would say it in words. Interval notation looks a lot like an ordered pair. X, Y. I'm going to write it in red. X, Y. But I don't mean this. It will look like that, but I don't mean it. Interval notation says, you know what? As this list of possible numbers continues to get lower and lower and lower, like -1 million, -1 billion, -1 trillion, it looks like we're approaching negative infinity. And We know that we have an upper limit. We have a number that is the highest number for the domain, and we can be exactly there. So we want to use a bracket, a square bracket. This is what we call interval notation. Now, which is the one you need to know the most? You definitely need to know how to write the domain using the less than sign. And you definitely need to be able to describe the domain in words. This other notation shows up, maybe more frequently later on in Algebra 2 and Precalculus, but you definitely have to know these two. So that's the domain for function A. Part B has the same relationship. Describe the possible x values. Are there ever x values that don't exist? And if they are, name them. And part C makes you focus on the fact that we have a filled-in circle versus an open circle. Filled in means closed. Not filled in means open. And there's a reason for this. One of these uses that symbol, and one of these uses the less than or equal to symbol. Can you figure out which is which?